Okay, so I'm going to do a couple more regression examples in this video. You're going to see or identify first by making a scatter plot if a curve is exponential, quadratic, or linear. So those are the three we're going to concentrate on. So again, we're in Excel. Select your data, including the XY, and we're going to go up to Insert, go over here to Charts, and I'm going to get all the different scatter plots. I do the one without any connecting. So it looks like that one is definitely looking exponential to me. So exponential growth. So I'm going to go over here to the plus, hit the plus, and go down to trend lines. I'm not going to click on it. I'm going to go over to the arrow, click on that, more options. Let me move my screen for a second. So more options comes up here. You may have to toggle through these to get this particular screen, but more options. I want exponential and display equation on chart, and if I could get a little more room here, display R squared value on chart. Okay, so once I do that, move my screen back, there's my equation and my R squared. We're always hoping for R squared to be as large as possible. This one's pretty exponential. It's a little off, but I mean it's very, very close. So if I go down to this next one and do the same thing and insert, scatter. Okay, a little bit of a slight curve here. This one might be exponential, it could be quadratic, but when it's that slight of a curve, I'm probably going to go with an exponential. So this situation, I'm going to close the X there, plus, trend line, more options. I'm going to go with exponential, and I'm going to reduce this for a second so I get my display equation on chart, display R squared value on chart, and move this up. So my R squared is a 0.9989, and if I were to go back in trend lines and do a polynomial with my equation and my R squared, then you see it's 0.9967. So it fits it very well too, but the R squared is a little bit less. I mean, this is pretty much exponential when I look at it. So that's the way we're gonna go. And if I continue on, go down to problem 3, and you can't see it, but you should be able to follow right now. Insert, scatter. That's definitely not exponential or linear. That is a polynomial. So plus, trend line, more options, and move my screen over. Definitely polynomial. And I'm going to click on display equation, display R squared again, expand my screen, and you see that's very well fit. I mean 0.9991. So definitely polynomial, in this case second degree quadratic. And things we should be able to do with this is, if I asked you for the zeros, quadratic formula. If I asked you for the vertex, then you'd use a formula for that. And get rid of this. Go on down to this problem 4. And you're probably faster at this than I am right now. So take a second, think about what you would do. Is it exponential? Is it linear? Is it quadratic? And I'm going to go with quadratic. So remember there, more options. I'm just clicking on the polynomial, and I'm clicking on display equation, display R squared, and that one's pretty darn close. Okay, so that's a perfect fit. And if I go to this last one, well, I've done 2 exponentials, 2 quadratics. Well, I'll guess for what this one is. That looks like a good old linear. And come down, trend line, more options, and I'm just going to click on linear, display equation, display r squared. And again, you see it's fitting it perfectly. Let me go up here for a second to this one, and let's say I don't like something here where it says trend line 2, so I'm going to click and hit delete. Maybe I got it. Okay, so that's gone. Alright, so if I look here, maybe I want more decimals than this, and one thing I could do is click on here. I like to do a right click, format trend line label, and what happens is it brings up this menu here, and I should be able to go into number, and you see how it updated already, then change my decimal places to 4 or 5. Let's go with 5. And right there you see I'm getting more decimals. So, and what I'm really wanting is this decimal up here for the K, so it will be more accurate. But that's basically fitting 3 different kinds of mathematical models to data. And your job here is to determine if you think it's polynomial, exponential, linear. And sometimes, like this one's not really telling you a lot, but I'm making the problems fairly obvious at this stage. All right, thank you.